Hello everyone, this is Yasmeen Abdrabou from Bundeswehr University Munich, and I'll be presenting our CHI poster under the title Think Harder, Investigating the Effect of Password Strength on Cognitive Load During Password Creation. This work is in collaboration with the University of Glasgow. In literature, three types of cognitive load measures were introduced. First, subjective measures, where the NASA TLX questionnaire is used as an assessment tool. Secondly, physiological measures, such as tracking pupil dilation, heart rate variability, and galvanic skin response, where the changes in these measures have been shown to correlate with different levels of cognitive load. And finally, performance measures, which captures how efficiently is the user performing a given task through mental effort and task performance scores. In the last decades, researchers have investigated the pupillary response for different types of tasks, where pupil dilation was found to be higher for more challenging tasks. Literature showed that pupil responses can be an indicator of the effort to understand and process information. It was also found that the pupillary dilation was larger while readers processed a complicated sentence compared to a simpler one. Until now, passwords are the most popular authentication mechanism. However, they are vulnerable to different types of attacks. For this, system administrators started employing password composition policies to eliminate attacks and to help their employees to create stronger passwords. They also started asking them to regularly change their passwords, which decreases their productivity. Literature also showed that users are aware of what makes a strong password, and this might suggest that putting more effort in creating a password might be an indication that it's a strong one. And this motivated us to investigate the relation between password strength and cognitive load inferred from pupil diameter. For this, we ran a lab study where we had 15 participants. 5 of them were males and 10 were females, and their age varied between 22 to 31. We used a 2B Pro glasses and Lenovo laptop to capture and record participants' pupil diameter. For evaluation, we used the mean pupil diameter and the mean pupil diameter change. Please refer to the paper for the equations. For the study design, we had a within-subjects design where participants were asked to create 12 passwords, 6 weak and 6 strong. The order of which passwords they should enter was counterbalanced using a Latin square. For the study procedure, participants were asked to sign a consent and demographics form. Then, we calibrated the eye tracker using 2B's 1-point calibration scheme. Participants were advised not to reuse a password they already entered. After each password entry, we asked participants to rate the password strength on a Likert scale from 1 to 5. We found that participants' pupil diameter is wider while creating strong passwords, indicating more cognitive load. We also found that the difference is consistent across participants and repetitions, and the smallest difference is 0.03 mm. In addition, using the mean pupil diameter change, we found that participants' pupil diameter dilates while creating strong passwords and contracts while creating weak passwords. We also noticed that after the third created strong password, participants' pupil diameter started decreasing. This might be due to participants finding a password strategy after the third trial, leading to decreasing the cognitive load. To conclude, in this work, we investigated the relation between password creation and cognitive load inferred from eye pupil diameter. We ran a lab study on 15 participants using a wearable eye tracker. We asked participants to create 6 weak and 6 strong passwords. We found that passwords with different strengths affected users' pupil diameter, giving an indication of users' cognitive state. We also found that creating strong passwords lead to pupil dilation, while creating weak passwords lead to pupil contraction. We envisioned that our findings can be integrated in interfaces to assess password strength without revealing the actual password of the system. It can also be used to optimize employees' workload for better productivity. In addition, it can also be used to suggest alternative passwords to the user based on their pupil diameter. And finally, suggesting verbal, visual, and spatial cues to help users creating unique memorable passwords. Thank you for your attention.